collection and sampling. And I like this first one, which of the items is not like the other. So I don't know if you remember that from like your Sesame Street days. You remember they had like a, you guys remember that? They had 4 things. And which of these, a little song along. So which of these items is not like the other, and why? And remember, we're dealing with measures of central location, measures of variability, measures of relative standing, and measures of linear relationship. Daniel. Okay. No, that is not the answer. No. So range, variance, and standard deviation, all measures of what? They're measures of variability, right? Okay. These are all measures of how spread out things are. Range, variance, and standard deviation. So you guys remember that? Yes. Mean is a measure of central location, right? So if we think about it, you know, these three, this one is not like the other, right? This is a measure of central location. This is a measure of variability. The other three are measures of variability. Is that too obtuse? Is that too like? You guys remember that? Yeah. They have like a fireman and a policeman and a mailman, and then they have a doctor. You know, like look at these things. You remember that? Yeah. So same concept. So which measure of central location is used for rates of change? Which measure of central location is used for rates of change? So these are all measures of central location, but which one do we use when we're dealing with percentages? Rachel? You guys remember the geometric mean? Remember, arithmetic mean doesn't work when we're dealing with rates of change, like percentages, so we have to use the geometric mean. Number 3, a perfect straight line sloping downward, y decreases as x increases, would produce a correlation coefficient equal to what? So a perfect straight line sloping downward, coefficient correlation is always between -1 and +1. So if it's a perfect straight line going down, it would be -1. Very good, -1. Number 4, what is the name given to extreme observations? Yes, very good. I heard someone say it. They're called outliers, right? And I even told a story about outliers. What is another name for the second quartile? Second quartile is the median, right? The second quartile is known as the 50th percentile. It's also known as the median. It's also known as the 5th decile, right? Because all we're doing is we're taking that 100% continuum and dividing it up various ways, yes? That's what percentiles does. This is a question from chapter 4, remember data collection sampling. We talked about that last Thursday. Which of the following is an example of non-sampling error? So we had 2 forms of error, sampling error and non-sampling error. Remember, sampling error could be reduced by doing what? How can we reduce sampling error? By doing what? More samples, increasing the number of samples. Non-sampling error was an issue with the process, okay? So errors that arise from the recording of incorrect responses. That's a version of non-sampling error. It's called data acquisition error. Errors that arise when responses are not obtained, that's called non-response error. And this third one is called selection bias. All 3 are examples of non-sampling error. So the answer would be all of the above are examples of non-sampling error. You have used the least squares regression method to estimate the line y is equal to 9,500 plus 1.5x, where y represents total cost of production at the Slinky factory, and x represents the number of Slinkies produced. What value represents variable cost? So remember, we said we can use this to break down cost into variable and fixed. So which value up there represents variable cost? Very good, 1.5. Where is fixed cost? Doesn't go away no matter if we make 0 or a million. 9,500, right? You guys recall that? Yes? Karen and Armando both have the same GPA of 3.35. However, the standard deviation of Karen's GPA is 0.5 and Armando's is 0.3. Who is a more consistent student? So that's where we use measures of variability to see like consistency, variability. So which one would be a more consistent student? Karen or Armando? Armando, because his standard deviation is lower, right? Meaning more values around his mean, his grade point average. In a given bell-shaped distribution, the mean is 100 and the standard deviation is 10. What percentage of observations would be between 70 and 130? So if we recognize that, we're going over 30 this way and 30 that way from the 100, right? Standard deviation in this case is 10. So we're going 3 standard deviations this way, 3 standard deviations that way. The empirical rule tells us what percentage are within 3 standard deviations. You guys remember? 99.7. If I said 80 and 120, that's 2 standard deviations. That would be 95%. And if I said 90 to 110, that's 1 standard deviation. That would be 68%. 68%. Let's look at, all right. So that is a sampling of the multiple choice. Any questions on that? So, really going to ask you about those measures, what they measure, how to use them. Really apply this. And I know some people think, hey, this is kind of silly that we have multiple choice in a math class, but it's not, because in reality, that's what you're going to have to do, is apply these concepts more so than calculate them out. That's what you're going to have to do. So questions on the multiple choice? Yeah. So here's what I thought about this morning. I'm not going to make you do number 2 manually. Okay, remember that was the geometric mean one, and I thought about it. I'm like, I'm not going to make you do that by hand, because we did that with Excel. You're going to do one today with Excel. So I think the problems that you will have, and they're not really big problems, but problem 1, I'll give you a set of data, and I will ask you to figure out the range. That's pretty simple, right? The range is the high minus the low. The mean, add them all up, divide by how many there are. The median is the middle observation, and the mode is the observation that occurs the most frequently. You guys recall this? You can do this? Should be pretty simple. And the other one really isn't a problem. It's an application of the empirical rule. So, this is calculations were performed against a bell-shaped set of observations for the annual salary of pro baseball players. The calculations show that an annual baseball player is $4.5 million with a standard deviation of $750,000. What is the range of salaries that contains at least 68%? So how would I get 68%? What would I have to do to get the range that contains at least 68%? Go ahead. Not percent rank. Using the empirical rule, how would I get the range? Yes, Rachel? Right, so the mean is 4.5 million. There's no markers in here. The mean is 4.5 million. So 68% is 1 standard deviation to the left, 1 standard deviation to the right. So I'd subtract it once, and I get 3,750,000. I'd add it once, and I'd get 5.25 million. That's the range for 68%. Does that make sense? I go over 1 standard deviation, which in this case is 750,000. What is the range of salaries that contains at least 99.7? Empirical rule tells us how many standard deviations do I have to go over to get 99.73. So 1 standard deviation is 750,000. 3 would be 2.25 million, right? 750,000 times 3 is 2.25 million. So I'm going to subtract 2.25 million to get 2.25 million. I'm going to add 2.25 million to get 6,750,000. And that would be my range for 99.7. Okay, so probably like 25 multiple choice and just 2 problems like that. And they're not really problems, they're more like, not really that hard. Because I want to focus on Excel. That's what I want to do for the most part of this class. So that won't take our whole class period, next class period. We'll probably do it at the, we'll probably lecture a little bit, and then I'll give you like an hour again to do, maybe not an hour, maybe like 50 minutes or so. Okay. So questions. So we'll have it Thursday, right? Because you guys feel pretty good about this or no? Gabrielle?
I've never feel ready.
You never what?
I've never feel ready.
You never feel ready ever?
No.
Oh, okay. So even if we went to like Tuesday, you still feel. What's that? All right. So here's let's do our Excel. So here's what I'd like you to do. Everyone, fire up your laptop. Remember, you can use books, you can use notes, you can use anything but communication channels. So I want you to go to in-class Excel exam, and I didn't make this available, but I'm going to make it available in a second. So maybe you have to refresh because I just made it available, but if you go to in-class Excel exam, you should see exam 2, October 4th, 2016. You guys find it? No? I just made it available, so you may have to go out and go back into it because to refresh it. But there are 3 problems. Okay, 3 problems. The first one, the file contains a random sample of 500 people who are asked to report the number of social media connections they have. These same people were also asked to fill a survey instrument to determine their level of happiness. Here is what I'd like you to do with this data set. Report the mean, median, mode, range, variance, and standard deviation for the field social media connections. You can do that all very quickly using one tool, if you remember. Assuming this distribution is bell-shaped, please use the empirical rule. I should have said rule there to interpret these results. So you're going to have to use the mean and standard deviation to do that, yes? Part 2, report quartile 1, quartile 2, quartile 3, and the 65th percentile for the field's social media connections. If you had 900 connections, what percentile would you be in? Okay, so that's part 2. And finally, using whatever statistical method you deem appropriate, is there a relationship between number of social media connections and happiness? So I'm looking for a measure of linear relationship there. You know, is there a relationship between the 2? Remember measures of linear relationship? Yes? Okay. Number 2, one task is to determine how much it costs to educate a student. To this end, a small private university like St. Francis recorded the number of students rather than the total cost in thousands of US dollars. The costs were adjusted for inflationary effects. The results can be found in the attached data set. Please do the following. Calculate the coefficient correlation. Is there a positive or negative relationship? Draw and label a scatter diagram. We're going to add a trend line, an R-squared value, and explain that. So that's part 2. That's the scatter diagram. And part 3 is a geometric mean problem. So please, you can use that template. You guys remember there was a template under chapter 3 that I built. You may have your own template that you used, but for that geometric mean problem, you may use whatever resource you want. So you're going to end up submitting 3 different Word files, right? One for problem 1, one for problem 2, and one for problem 3, because they're like 3 different assignments. And I'll grade them each independently. Dan, you had your hand up. Yes, everything always in a Word document, okay, with your narrative, okay? Go.